Welcome back. Let's talk about covalent bonding. As you can see, this is section 7.2 in your book, and we are going to be talking about covalent bonding. So when we have a metal with a nonmetal, we tend to transfer electrons, and this is an ionic bond. When we have two nonmetals bonded together, they tend to share electrons. And when we share electrons, that's a covalent bond. Covalent bonds are formed between atoms that have similar abilities to attract electrons. And there are a couple of types of covalent bonding. So let's look at the hydrogen molecule, H2. It's one of our 7 diatomic elements, and you should remember those. And I'll repeat them here. Hydrogen, then you go to element 7 and you make a 7. So hydrogen, and then nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Those are the 7 you need to know. So when we form a hydrogen molecule, each hydrogen atom has 1 electron, but as in all things, we want to achieve a noble gas configuration, and for hydrogen, the next noble gas is helium with 2 outer electrons, or 2 total electrons. So if we are allowed to get those 2 atoms close enough, we can actually form a bond. And now it would look like the noble gas helium. This is also true if we're doing something like HF. Fluorine just needs 1 more electron. Hydrogen needs 1 more electron. If they share electron with each other, then they each have an isoelectronic configuration with their nearest noble gas. What happens when we're forming H2? Well, if you start over here on the very right-hand side, we have 2 hydrogen atoms that are infinitely far apart, and there is no attraction between the 2 atoms. As we push those 2 atoms closer and closer together, they begin to feel an attraction to each other. And as they feel an attraction for each other, their energy is decreasing. They're getting more stable. And they're actually releasing this energy as they form this bond. As we continue to push them closer and closer together, we reach a minimum here in energy. And this minimum point is the distance between these 2 nuclei that is the ideal bond length, or the ideal bond distance. And we use that as the bond length. If we continue to push them closer and closer together, now we start to feel a repulsion between the 2 atoms. We're pushing them too close. And so the potential energy would increase again. So this minimum in potential energy is the ideal bond distance. So to break chemical bonds, energy must be added to the system, and that is an endothermic process. The formation of a chemical bond results in the release of energy, which is an exothermic process. The bond makes each atom more stable and therefore in a lower energy state. That's why as we're pushing them together, they're decreasing in energy, getting to this bottom point. All covalent bonds involve sharing of electrons, period. No exceptions. But they're not always shared equally. So there are 2 types of covalent bonds: nonpolar covalent bonds and polar covalent bonds. Nonpolar covalent bonds is equal sharing of electrons, and this ideally happens with 2 atoms of the same type, N2, H2, O2. If we have 2 different elements, then we're into some type of a polar covalent bond. And the different types of covalent bonds arise from electronegativity differences. So, electronegativities we studied last chapter. and it is the measure of the tendency of an atom to attract electrons towards itself within a bond. Linus Pauling came up with this scale, and he experimentally determined all of the values. And the electronegativity trends on the periodic table is it increases across a period from left to right. And it decreases as we go down a group from top to bottom, or it increases from the bottom to the top. And so here's a chart showing that, and it also has the electronegativity values on there. Noble gases are not shown. Why would that be? I think it comes back to the electronegativity explanation or definition. So a pure covalent bond is equal sharing of electrons, and it's formed when two atoms have the exact same or very similar electronegativity values. So this would be any kind of diatomic element, and we consider carbon to hydrogen to be pretty pure nonpolar covalent bond. There's an electronegativity difference, I believe, of 0.4 or 0.3, something like that. Polar bonds, or unequal sharing, forms when we have a significant value or difference in electronegativity. And the more different those two elements are, the more polar it can be. And it increases as the difference between the two atoms in electronegativity. So if the electronegativity, or the atom with less electronegativity will be partially positive, and the one with a higher electronegativity value, or En, will be partially negative. So, pure versus covalent. And this is kind of arbitrary, and in fact, you don't need to know this, but I'm giving you kind of some cutoffs. I won't ask you this. There are a lot of exceptions. This is just a general guide. Don't hold me to it. So if it's less than 0.4 difference, then it's pure covalent. If it's between 0.4 and 1.8, it's polar covalent. And then ionic is if it's greater electronegativity difference than 1.8. So here's just a more graphical way of looking at it. So we're going to start with Lewis structures on our next video. Thank you for watching. See you soon.